So now we'll work on some single sum problems. The hardest part of all of these problems, no matter whether they're single sum or annuities, is setting them up. You can look at the tables and pick a number, but if you don't have the problem set up right, it just isn't going to work out. It's not going to end well. So I want to go through a few, and I have a fairly foolproof method of doing these that tends to work. And it involves asking of just a few simple questions for each one. So let's start off by moving this 400,000 over so we can see what it says. This guy wants to have his own fishing boat in his retirement. He's got an inheritance of 400,000. He estimates that the boat he wants will cost 300,000 when he retires in 5 years. So how much of that inheritance does he have to invest now at an annual rate compounded annually of 8% to have enough at a retirement to buy the boat? So the first thing I usually ask is, do we need to know the present or the future amount? So here we know that it will cost 300,000 in 5 years, but it's how much does he need to deposit now to get there? So what we need to know, it's like, do we need to know the present or the future? We need to know the present. Is it a single sum or an annuity? Well, we're talking about one lump sum of the 300,000, so it is a single sum. So the answers to those two questions, we can ignore the next two since it's not an annuity. The answer to these first two questions gets you to the right table. You're going to go to the present value of a single sum, or the present value of one table. So that gets you that far. Then, what are the number of periods? Well, it's 5 years, and the appropriate interest rate is is 8%. Okay, so 8%. And so this gets you to where you need to go on the table. So you get to the present value of a single sum table, you go across to the appropriate interest rate, down 5 to 5 periods, and that will get you your factor. So so then, well, what do we do once we get the factor? So you're going to get, what you're looking for is the present value factor of a single sum for 5 periods at 8%. And so that's usually how we show the factor there. And if you take that factor and you multiply it by the 300,000, you should get the amount that you need to deposit. Okay, so amount needed to deposit today. Okay, so let's see how that works out. If we go to the tables, I'm just going to go right across here, we get a factor of 0.68058, and so if we want the amount we need to invest today, we take the 300,000 that we need in the future, bring it back to the present, and we have to deposit, or he has to deposit, 204,174. So you can see we're setting up the problems. You have to, first of all, does the answer make sense? You know that if you need 300,000 in the future, the number that you need to deposit today is less than that because it's going to be earning compound interest over the 5 years. Okay, so now let's do the same problem, except it's compounded quarterly. Okay, so now how does this change things? When we go through the same procedure here, we still need to know the present value, whoops, and it's still a single sum, so that gets us to the same table. But now, when it is compounded quarterly, that means there's 4 interest periods in each year. So you get 5 years times 4 interest payments, so your N is going to be 20, your number of periods. The interest rate, 8% is the annual rate. So if we have 4 interest periods each year, we've got to divide that by 4. So when we go to the tables, we're going to go to 2%. Okay? Oops, that didn't work. There we go. Okay. So now let's see what happens when we do that. We answer our questions, we get our factor, multiply the 300,000 times the factor, and you can see that before we needed 204,000 today. It makes sense that we would need less if it's compounded quarterly, because it's going to be earning interest that much faster. Okay, so those are those two. Let's see what we do next here. Okay, so let's look at the future value of a single sum. This is our hardworking and frugal math-based student. Managed, I think I have a typo there, managed to save up to invest $1,000, earning 8%. How much will it earn at the end of 5 years? So, now we ask ourselves, do we need to know the present or the future? Well, we need to know the future. We want to know, we know we have 1,000 now, how much is it going to be in the future? So we need to know the future. It's a single sum, and it's 5 years at 8%. So here, we're multiplying what we have today times the future value factor to get how much we will have in the 5 years. Okay? So answering this question, what do we need to know, the present or the future, that's key. This gets you to the future value of the single sum table. The next two questions get you to the right factor. Okay, so now this same math-based student, you can see that if it is compounded quarterly, well, let's see, wait a minute. Did I not change that? Okay. Yeah, this should be quarterly. It's compounded quarterly. So now there'll be the 20 periods, because it's 5 years times 4 periods each year. And you cut the interest rate. You have to divide the interest rate by quarters. And so you can see when it's compounded faster, you're going to end up with more at the end of 5 years. You're getting 1486 as opposed to 1469. So more compounding is better when you're earning money. Okay. So now the next sort of problem we get to is, what if we know the future and we know the present, but we don't know the interest rate or we don't know the end? So we'll see how that works.